Okay, I'll make a start. Good afternoon, everybody. You're very welcome to this State of the Science webinar that's being run by the New Zealand Agricultural Greenhouse Gas Research Centre. We're based here in Palmerston North, in the beautiful Manawatu. And today's topic is all about animal breeding, which is really starting to emerge as an important mitigation approach for New Zealand grazing systems. We're really delighted to have the presenters and the chair here today. So without further ado, I'd like to hand you over to Dr. Harry Clark, who is the director of the NZAGRC. Harry will be taking us through the session today. So thank you all for joining in. I hope you enjoy the State of the Science webinar. Harry, over to you.
Thank you, Sinead, and welcome again to everyone. And today, really pleased to be able to welcome Lorna McNaughton from the Livestock Improvement Company, who's going to discuss the work she's been doing on selecting low-emitting dairy cows. And Lorna is not new to this game. Laura and I first worked together around about 15 years ago when we nearly killed ourselves measuring about methane from around 700 cows. So she's had a long time involvement. Now she's leading a program that is really trying to put this into action by measuring methane in young bulls, most of which will go on, a selection of which will go on to sire a very large proportion of using the dairy animals. So we've undertaken some preliminary work, and now we're actually moving into the more full measurement phase. And Lorna is going to talk to us around the first year's results of the work that is going on jointly with LIC and CRV Ambreed up in Hamilton. The talk will take around 25 minutes, and there will be opportunities to ask questions then. Anyone submitting questions, could you please put them in the Q&A, not in the chat function, please? And then we will try and get through as many of those questions as possible with Lorna. Any that we can't answer, we can try and answer later. But without further ado, I'll hand over to Lorna.
Thank you, Harry. And hello, everyone, from the not so sunny Waikato at the moment. So I'm presenting some data from our first year of the trial. So back in 2020, we had a pilot trial, got underway, and then last year we managed to get into a main trial, and we've continued that this year with measurements ongoing at the moment. So first, why breeding? So we definitely don't think that breeding is going to solve all farmers' issues around methane, but we do see breeding as another tool in the box to help farmers meet their methane reduction targets. The nice thing about methane is it's permanent and cumulative, so the gains add up over each generation. And particularly in dairy, the widespread use of AI means that we can disseminate those good genetics quickly around the country. So typically bulls will end up with tens of thousands of daughters out milking on herds around the country, and the odd elite bull will end up even with hundreds of thousands of daughters. So what were we setting out to do here? So first task for us was to figure out what equipment we needed, order that equipment, get it here and get it set up, a much bigger task than I initially had thought. Then we were going to measure feed intake and methane production on bulls from the LIC and CRV progeny test, and then using that data to start estimating genetic parameters. And just bear in mind, genetics is normally a very big numbers game. Here, we've only got a relatively small data set, so we're very much in the building up data phase to give us at least a taster of what's to come. So when we're measuring methane, it's really important to understand how much and animals eating, as a lot of the variation in methane production is just due to simply how much an animal eats. So if you have your dairy cows in a barn, you can achieve that relatively easily. Obviously, in our pasture-based system, it's a bit more of a challenge. So we thought, why not measure bulls? And to do this, we thought, well, we'll bring the bulls inside, and that makes measuring what they are eating a whole lot easier. So we end up with 8 experimental pens across 2 locations. CRV already use barns as part of their existing bull rearing facility. So they were able to modify a barn, and the picture on the right there is the front half of the barn, which is modified for the methane setup. And at LIC, we built a barn specifically for this methane trial, and we shamelessly copied the CRV barn in terms of design, which made getting it all set up a lot easier. So in terms of the timeline, every year, LIC and CRV buy elite genetic merit bulls from around the country. Most of these bulls are born in the winter or spring. There are a few born in the autumn period. And then we go out and we inspect these animals, and we do a DNA test to make sure their parents are who we think they are. And we use that DNA test to also have a look at their genomic merit. So we estimate how good they are based on their DNA sample. Then we select about 10% of those animals, and we purchase them and bring them onto site at either LIC or CRV. So that's probably around 300, 350 animals across the 2 breeding companies. Those animals arrive during the summertime to our centres. We get underway with methane testing at LIC in February. Then we run through till about June, and then we ship off the equipment over to CRV, measure the bulls there, and then in spring, those bulls are used in progeny test herds to generate around about 80 daughters per sire. So these are the elite bulls who will go on to sire the vast majority of the dairy cows in New Zealand. So we're not selecting from a sample of the general population, we're selecting from a sample of elite genetics. So that was our plan. Last year, we did get the first pen up and running in February, and we finished our trial work at CRV on the 14th of December. A little later than we had initially planned, just due to delays in getting the equipment here and getting everything fully up and running. So it was quite a long year last year, but I think it's been worth it. So what do we actually do with the bulls? So they have 35 days in the pens. So we can't measure all 200 bulls at once that we have at LIC. We do 3 different batches at LIC, and then we do 2 different batches at CRV. So we feed out in the paddock for about a week before they come into the pen. So they are at least partially adapted to the diet before they come in. And then they have a week of further getting used to the diet and learning how to use the feed intake and the methane measuring machine. Then we measure for a further 28 days, and we use that data in our analysis. During that time, they're measured 3 times a week for live weight. And then right at the end, we collect a rumen sample, and that goes off to ag research for some other project work around the rumen microbiome. You can see us extracting the rumen sample there. If it's all going well, it takes 2 to 3 minutes per bull. It's a pretty quick process. So how do we measure methane? There's a few different ways out there. We use what's called a green feed machine. It's made in America, and they're it's getting to be fairly well developed technology now. They have their foibles, and we have a very good engineer who helps us keep them up and running. But if you keep up the maintenance, they're generally pretty reliable. So you can see the front of the machine to the right there. So that's what the bulls see in the pen. And then you can see a schematic on the left. So it's shameless bribery to get the bulls to put their heads in. there's a feed bin on top, and you can see where the RFID reader is in the schematic. So when the bull puts his head in, his tag is red, and then we can program how many drops of pellets they can have and how far apart those drops of pellets are. And the idea is to keep their head in for at least 3 minutes, so we get a good sample of their breath, and we get to capture some of the burping that the animals do. So on average, they're going to burp every 1.5 to 2 minutes. There's a big fan in the chimney, so that means that all the animals' breath goes up the chimney, and a little subsample is taken and then analysed for methane and CO2. There's also a head position sensor in there, and that's around making sure the animal's got his head far enough in to be getting quality data. And then in terms of feed intake, so we use a type of feed intake bin that's pretty commonly used around the world. We were lucky enough to get a brand new model of the bin, so that has given us a few additional challenges in figuring out exactly how it works in relation to the old model that we tested in the pilot trial. But overall, it's up and going, and feed intake's going pretty well now. We feed a forage-based diet, so obviously most New Zealand dairy cows are out there grazing pasture, so we wouldn't want to be feeding a total mixed ration. But we also need to be practical, and we're looking for genetic variation here. So we want to keep the environment as similar as possible. So grass, while it would be ideal in that that's what the cows are eating, changes so much over the year. We'd have the animals at CRV eating a very different feed to the animals at LIC. So we feed lucerne hay cubes. Ag Research have done some work showing that the ranking of animals fed either lucerne hay cubes or ryegrass and white clover is pretty similar in terms of the methane production. And they're very high dry matter, so we can feed the animals once per day, and they've got plenty of feed left when you come and top them up the next day. We also feed the pellets that are in the green feed machine, and we try and keep these to less than 10% of the animal's diet. So we really are getting that strongly forage-based diet to represent what happens in real life. So these are just a couple of shots of CRV last week. We've got usually 4 video cameras per pen. So if we have anything strange going on with the data, we can go through and see exactly what was happening and try and figure it out. You can see the green feed machine sits in the alleyway, and in the pen, there's also a little alleyway. So the animals can get in there and they haven't got their neighbour coming in behind them or from the side, putting their methane containing breath in and contaminating our samples or just disturbing the measurement period. We also have a shorter kind of alleyway on the feed intake machine, and that's for the same reason, so they can eat in a bit of peace. And so if one wants to push the other one out the way, we have enough time for the gate to go up and to capture the change of animal. So we've got better data integrity that way. At LIC, we have 2 feed intake bins per pen, and we run up to 12 bulls per pen because we're starting in February. The bulls are a lot smaller, whereas at CRV, we just need the 1 feed intake bin, and we tend to run 5 or 6 bulls in the pen. So what have we been capturing? So last year, with all the fun with getting everything delivered and set up, we ended up having 259 animals went through the pens. Of them, 5 refused to visit the methane machine. The vast majority of the animals that do go and visit the green feed tend to go regularly, so we allow them to go up to 5 times a day. You don't see many animals that don't go the full 5 times. Once they've got a taste for it, they're very keen to go and get their intake of pellets. And we try and arrange it so we get a good distribution of those visits over the day. In 2022 so far, so that's the LIC trial, which we've completed, we measured 226 animals, and again, 7 of them didn't visit the methane machine. So we're getting close to 500 measurements. In fact, with what's already been completed at CRV, would be just over 500 animals measured so far. So still a small data set from a genetics point of view, but building up nicely. So how much did the animals eat? So what was quite interesting to see here was how consistent the entry weights are between LIC 2021 and LIC 2022. So that was the day 0 live weight for the bulls, so the day they went into the trial. You can see that the CRV bulls are a lot heavier when they go into the trial, and that's obviously because they're older, and particularly last year with our measurements running so much later, CRV bulls were even bigger. What's interesting to note this year is the live weight gain per day is almost identical between the two LIC trials, but the feed intake is about 1 kilo different. So we are waiting for our nutritional analysis, but that would suggest that the feed quality this year is a bit less than last year. So what did we see in terms of the distribution of methane production and dry matter intake? So we do see a good bit of variation, so that's good. And on average, the bulls are producing around just a bit under 230 grams methane per day, and eating on average about just over 10 kilos dry matter. Then one of the things we're quite interested in is the amount of methane the bulls produce per kilogram of feed eaten. So we see quite a lot of variation in this measurement too, and an average of around 22.4 grams per day. And on the right here, you can see some of the bulls at LIC in the pen. So we have a little toy in each pen, so they've got a bit of enrichment, and we also have a scratching post for them to keep them a bit entertained while they're inside. So then the bit you've all been waiting for, so the genetics. So I'm going to present just 2 numbers today. So the heritability, so that's the proportion of the variation in a trait that arises from genetics. So what a very highly heritable trait is height in humans. So heritabilities for that range up to about 0.8. So that's 80% of the variation is due to height. It's due to genetics and height. So if you look at someone's parents, you can have a fairly good prediction of how tall they're likely to be. The other number we're going to look at is the repeatability. This includes a permanent environment effect and a genetic component. And it's defined as the extent to which measurements on the same object under similar conditions correspond with each other. So some measurements are highly repeatable, i.e. you can keep the environment nice and consistent and they don't change it much, and some are not so repeatable. So a low repeatability trait is something like whether a cow conceives in the first 42 days. If you look at just one record for her, it doesn't give you a very accurate picture of whether she's likely to conceive again in the next 42 days next time. But if you have 10 records for that cow, then you're pretty confident that she's a high fertility cow. And reproduction is an example of a very lowly heritable trait. So we're hoping that methane is closer to milk production rather than fertility in terms of the heritability. So what have we found? Again, this is on a very small data set. These genetics are only on year 1 of the data. We're just crunching, including the LIC data from year 2. So heritability less than 0.2 is lowly heritable, but there's still significant genetic variation there. Milk production traits are typically in the range of 0.2 to 0.3. Some are a little bit higher. And the repeatability is also in that kind of low to moderate range. So we've got methane production per day there coming in at 0.17, and then methane production per day adjusted, and that's been adjusted for feed intake. As I mentioned at the start, methane and dry matter are highly related, so phenotypically, so that means what we actually observe, and genetically, they are both positively correlated. That is, animals with a higher methane production tend to have a higher dry matter intake. But what's really encouraging is when we look at just the genetic variation, about 29% of the genetic variation we see in methane production is due to genetic variation in dry matter intake. So that means we've still got 71% of the genetic variation in methane that we can kind of play with and potentially select animals that produce less methane but still eat plenty. Because for dairy cows, we definitely don't want to be selecting animals that are eating less, that probably would produce less milk and maybe have more of an energy squeeze in early lactation. So based on year 1 results, one of the things we're looking at is, can we improve the repeatability? So with a low repeatability trait, generally, if you measure the animals for longer, you can improve the repeatability. So this year at CRV, we're going to measure the bulls for between 70 and 75 days and see just what that does. If it works, then we're going to have to get our thinking caps on and see exactly what we can do to measure the LIC bulls for longer. So we have a lot of bulls to get through at LIC, and we don't have a particularly long window, but there might be some smart things we can think about there. And then what about some alternative measurements? So those of you who are familiar with the great work that Ag Research has done with their sheep will have seen they use portable accumulation chambers to measure methane in the sheep, and Ag Research have now got a single prototype for cattle. So this is currently going through the approval of the ethics committee. They've put some dairy heifers through back in late May, and things actually went pretty smoothly from what I hear. So if that all goes well, we'd really like to measure our bulls through this chamber next year. How many? Hopefully we could get a lot of the LIC bulls through. They're not exactly sure on the size requirements for animals for the chamber at the moment. And hopefully some of the CRV bulls might be small enough to also go through. And you can see that a portable accumulation chamber is somewhat portable, so that might provide the opportunity to measure daughters out on farm. You don't get the feed intake measurement, but if you've got some animals that have got feed intake and methane, you can cope with some just methane measurements alongside. So just measuring the bulls isn't the end of our process. We also need to understand how the methane trait relates to milk traits. Now we'll get some of that through the progeny test scheme daughters of those bulls, but we do want to know, do the daughters of the low or high methane bulls differ in methane production? So we're planning a trial at Pamu this year. So insemination's taking place in October. Calves being born in 2023. We're looking to generate between 300 and 400 calves, aiming for about 300 to go through first lactation. So those animals would have methane measurements in 2024 with a kind of similar protocol to what we're doing with the bulls. Perhaps also some portable accumulation chamber measurements. And then in that first lactation, we'd be studying the milk production in detail, looking at milk composition in detail. So there's some work out of the sheep project to indicate there could be some fatty acid differences. So we'd want to look at fatty acid composition quite closely, and we'd hopefully measure a subset of animals for methane while they're lactating. As you can imagine, that's a little bit trickier when you've got the milking process to fit in around. So that's where we've got to in the last year. So we can measure genetic variation. That was one of our questions. What was our measuring protocol going to be good enough to find the genetic variation that we thought was there? But we do have a small data set, and yeah, we're off to a promising start, but there's a long way to go yet. So before I finish up, I'd just like to say thanks. It's been a really big team effort. There's a lot of people involved in the project, and yeah, we wouldn't have been able to do it without the large team sitting in behind it. So thank you.
Thank you, Lorna. That's really, really helpful, really interesting talk. Now it's really over to the grilling part of this, when you get to answer the questions. I've got a couple for starting. One is a very straightforward question, I think, around we've been breeding low-emitting sheep since actually, I think 2004-05, when the first work started on that. How do your measurements and your findings compare with those for sheep? And I'm thinking very particularly around the numbers you presented on heritability, repeatability, etc.
Yeah, so our numbers are pretty similar, probably a little bit lower than the sheep work. So some of the sheep work on methane is around 0.9 for lambs through the pack chamber, or 0.19 and 0.2 for ewes. The repeatabilities are ranging from around 0.33 up to around 0.55. So the repeatability is perhaps a little bit higher, but definitely kind of in that ballpark. And overseas in cattle, we've definitely seen repeatabilities kind of in the ballpark of 0.1 to 0.2 where we've seen.
Yeah, another really important question from a practical perspective is, you've started the program. How long would it be before this would be practically available on farm to farmers? And a subsidiary question would be around, well, how long and what would the likely size, do you feel, of the reduction that could be throughout the industry if this was widely taken up?
So assuming we find what we hope we'd find in the daughter trial, I think 2026 or 2027 could potentially have low methane bulls available. I guess the farmers, like the bulls we're testing, are going to be used on farms around the country anyway. So the farmers are going to be getting some low methane genetics. Unfortunately, they'll also be getting some higher methane genetics as well. But I think 2026 and 2027 is realistic. In terms of how much progress we can make, that depends on how much pressure we put on the trait. So there might be some farmers that are very interested in it and put a lot of focus on it. They'll make more progress, but we think maybe a kind of 0.5% to a 1% reduction per year is potentially achievable. Yeah.
And just a subsidiary to that one was, how would you see it being accounted for in any accounting framework? For example, like there's a new pricing mechanism put forward by Iwaka Ekanoa. How would you envisage you would try and quantify this so it could be recognized in the pricing framework?
So if there's a carbon price, then BW is an economic index. So in theory, you could look to incorporate it into BW and use the economic values to achieve the weightings. So that would be a way to account for the economic cost and to quantify the benefits that way.
Okay, some other questions, again, quite practical ones. Do you feel that you've got enough statistical power at the moment? And what, particularly as you go on to the daughters, what would you need, the numbers of animals you need to be confident you have the right statistical power here?
So that's $1 million question. That's why we're adding the current year's data from LIC in before we do the bull selection. So we'll be selecting from around 480 bulls. The idea is to select as few of them as possible from the absolute extremes of the distribution. So hopefully we'll be selecting about 30 bulls, so less than the top 10%. We're just crunching the numbers to know exactly how divergent they will be. Our aim is to get the semen in the cows, keep crunching those numbers and make a call on whether we think the daughters are going to be divergent enough to spend the money to measure, or to say, hey, we need another year of data. So it's an ongoing process.
Okay. Thanks, Lorna. I've got a few questions here that were literally around beef. Will the work you're doing on dairy animals be translatable and be useful to inform any work on the selection of low-emitting beef animals?
So we certainly
with that reduction you're seeing, you know, your 0.5 to 1% reduction per year, do you feel that that could be repeated in beef animals, or is it really too early to say that at the moment?
I don't think I can quantify the reduction in beef, but I will say that we're working with beef and lamb around setting up processes to measure beef bulls through probably a similar protocol. I don't see why they wouldn't find similar variation to what we're finding, but there's no reason why not. I guess for beef, one of the options you do have is trying to finish animals sooner and get the animals off faster, and that can make quite a big difference to an individual animal's methane emissions, which is an option we don't have so much in dairy.
Yeah, another question around this, would you feel, do you have any information at all, and I know it's only small numbers you're using, that there's any differences in breeds such that Friesian would be any different to Jersey, etc.?
So when I had an initial look, it does look like there was a small breed effect, but then when I looked at dry matter, it all kind of balanced out. So basically the Friesians were producing a little bit more methane, but they were also eating a little bit more. So when you look at the methane per unit of dry matter, we're not really seeing that breed effect come through. And certainly, and we've had a quick look at who we think the bulls we could use might be, and there's a good spread of breeds there. So the jerseys aren't out on top yet. I know there's a couple of people who are betting on the jerseys.
Yeah, we've had a really, a question that I think is really grounds us a little bit. We always use acronyms, etc. Can you explain what BW is? Breeding worth?
I see. Yeah, so BW is breeding worth, and it's probably it is the index that's owned by the dairy industry, and it's what we generally use to compare the genetic merit of our cows and our bulls around the country, and it's expressed in dollar terms.
Thank you. But just ask someone to clarify your answer around how you account for any reductions. You actually mentioned the ETS, but did you imply that you don't see that it could be used in Hiwaka Ekanoa, or were you using the ETS as a generic implication for any accounting framework?
Yeah, I think it's a generic. I have no particular preference. I think, yeah, it should be made as simple for the farmers to account for as possible.
Thank you. And another broad question, what's happening internationally, and are others taking a similar approach to the approach we're taking?
So as far as I'm aware, we're the only ones doing bulls on a large scale, and I guess that's because mostly overseas the cows are housed, so it's a little bit easier to measure the cows. The Dutch have done quite a lot of work with sniffers and milking robots. So they've just published some work with kind of similar repeatability and heritability to what we've seen in our study. The Norwegians are buying a lot of green feeds and doing work with cows with green feed machines. So the Australians have done some work and then their funding got cut, but I suspect that might get picked up. Yeah, there's a lot of programs kind of underway. I don't think anyone has actually got it implemented into their breeding system fully yet.
Right, yeah, it's one question I perhaps might need you to interpret. Is, would you exclude high methane genetic bulls from the bull teams?
So I guess once we've got more evidence, then perhaps we would, and it would, so I guess that's like an LIC or CRV question. It would probably depend a lot on what the trade-offs are. So if the low methane bulls came with some undesirable trade-offs, then it would be much less likely.
Okay. Yeah, another one along the efficiency side. Would you be trying within your analysis to look at efficiency and checking whether any breed has a benefit when it came to methane per kilograms of milk solid? Well, obviously that has to wait till you get your daughter results, but would you see that that would be an analysis you would undertake and obviously publicize, etc.?
Yeah, I think so. We've got a heap of data now, and we're actually looking for a PhD or a master's student to come and start trawling through some of that data. So if anyone online knows anyone, please get them to get in touch. Because yeah, we do have, it's funded. It's hard to get good students. They're in demand.
Yes. I've got one more, which was, perhaps you've answered this a little bit yourself, is would you be looking for the end result of this to be a genetic marker for animal selection? And then the subsidiary question, would you feel that that would be transferable to beef bulls?
So we're a long way off having enough data to do genetic markers. So to do kind of standard genetics, we want kind of that 1,000 to 2,000 animals. To do genomics, we probably want 5,000 to 20,000. So as we build the data set, then definitely we'd look to see what we can do with genomics, but that is not going to be a short-term thing. But if we did find a marker, I can't see why it wouldn't translate to beef, and that it's quite a kind of basic evolutionary thing. But you never know until you test it out.
Yeah, there is one question which which relates to productivity, and I'll try and generalize that a little bit more, which is around the trade-offs. You know, within your, I know it's early doors, but do you feel that are you seeing anything in your analysis that results in any trade-offs, i.e. with low methane, would you sacrifice some productivity so that might change methane per unit of production in the wrong way, despite it reducing emissions, etc.? And you know, but it's a more generic issue around, yes, we might be able to reduce methane, but what do we do to the other traits? And what's the relationship between the low methane trait and other, you know, positive traits that you're trying to select for? Perhaps it's too early to ask you that question.
I think for our data, it's too early, but there is some published data to suggest that there is a positive correlation between methane output and milk production. And that's basically driven by the higher yielders needing to eat more.
Right.
So we are going to have to be careful in the selection. We'll be looking for animals that fit outside the general correlation. And that's what we do with fertility. Like milk yield is negatively correlated with fertility. And when we didn't select for fertility, we suffered the consequences. But now kind of correcting that, and you can, over time, make progress
Right, yeah. But presumably you make slower progress on a single trait because you're selecting for multiple. And that could be a downside, that you actually, there is a cost because you have a slower progress on the other traits that you want.
Yep, there's always trade-offs. And we just need to understand what they'll be.
And again, another approach, another question, which I think perhaps is a little bit early yet, is around, do you know anything about the mechanism of action between, you know, the genetics of the animal and the microbiome itself?
So we don't yet, although ag research do have data to suggest that there are microbiome differences in high and low emitting animals. And I think they're just in the process of understanding what they mean. For us, it would be great if we could do a rumen sample, and if that provided some predictive factor for an animal's future methane production, but we're a long way off that yet.
Right. And again, a question, do you have any feel for how a trait like a trait where you've bred for low emitting animals would interact with, for example, a feeding approach, feeding 3-NOP, and as to whether they would be synergistic, antagonistic, or whatever?
I don't think we understand enough about the mechanism of action of the genetics yet. Like, we know how 3-NOP works. So yeah, I don't really know how it might line up. Hopefully synergistic, but
well, I think the nice thing is we now have something like 3-NOP, and we have low emitting animals that we just about at the stage where we can undertake that work. So I think the problem's been before, we haven't had a reliable feed additive approach to add to the low emitting animals to even answer that question. So I think it's a great question, and it's something I think we're moving on to.
Yeah,
I've got a couple of questions.
We'll be following the sheep again.
Yeah, well, I mean, obviously we can use the sheep as models for what happens in the cattle, which has been done before. I've actually got a couple of questions of my own. Is that you talked about, you've got the farm feed bins. Do they allow you to look at the pattern of intake over the day and relate that to the visits that the animals make? Because I'm always worried about bias in relation to when the animal puts its head in relative to when it last had a feed, and whether if you take enough measurements over enough days, it evens it out, or whether there is a potential bias within the pattern in which the animals eat and the pattern in which they go to have a methane measurement taken from the CLOC system.
So we certainly do have that data. Figuring out how to use that data to answer that question is kind of the next step. And again, where's that PhD student?
No, because I am, it is an interesting one that if you try, because we don't quite know if we're feeding something like 3-NOP at pasture, can you vary when you would feed it relative to the intake to get the best methane reduction? For that, we'd need to know the pattern of intake and the likely times when animals go to the methane measurement system. So that's it. And just another one which came from actually a bit of a throwaway remark you made, which was around trying to get it so animals could go into the methane measurement system without being bullied and whatever. But that led on to something you said, you tried to arrange it such that the methane measurements were spaced out. How do you do that? And did you have any actual behavioral issues that make it difficult? Because animals are great if there's a feed attraction, and the bullies will keep everyone else out. Do you have any behavioral issues that you've had to overcome for the practical measurement of these animals?
Yeah, so in terms of how we do the spacing out, so you're able to program the green feed machine to say you're not allowed to come back for another 3 hours once you've had your pellets. So that's how we achieve the spacing, is doing that. We're only running up to 12 animals per green feed machine. So we're not utilising that green feed machine enough, I don't think, to see animals guarding it. We may see a little bit of that in the training period. So we have to, when we're teaching the animals, we have to watch quite carefully, because the ones that get a taste for it early, we give them unrestricted access when it's in the training period. And so if we don't quickly start cutting back their access, they will keep going and going and going, and let the shy ones aren't so keen to go in. So we have to be very much onto it in that training period. But yeah, in the main trial, I think we've got few enough animals per pen that there's plenty of time for everyone to get a feed.
Just on one final question, and I think we really have had an excellent selection of questions just before we finish. I was intrigued by your other measurements, and you mentioned portable accumulation chambers. Do you see any hope for even more rapid measurements? Particularly, I'm thinking when you go to the daughters, that there could be a milk test, there could be some kind of microbial test that might come from a saliva, etc. And would you see that that's your long-term aim within this? Because even going out to the number of animals we may need for daughters, it starts to become logistically difficult, A, and B, exceedingly expensive.
Yeah, I have some hope around like that detailed milk composition, given the fatty acid differences they're seeing in the sheep, and you can kind of figure out there could be some mechanisms for that to happen from the changes in the rumen to the milk fatty acid composition. So I'm intrigued to see what we find there, but I don't think I've got any firm hopes yet.
But you also mentioned sniffers being used within the milking shed in Holland and Belgium, I know. What are your views on that, and whether you think that is a way forward? And even things like mid-infrared milk spectra, do you have any views, and have you looked at that data to think, well, this again is something that we could do more rapidly to get the large numbers we need at the reduced cost?
So if we do see fatty acid differences, then that's potentially something we could pick up with MIR. I think thus far, MIR has a few challenges around standardization. I know we've just had someone complete a PhD on exactly that topic, and it's not simple, but there's definitely potential there if we find the right differences. I think sniffers, yeah, it would be cool to get sniffers set up in a rotary and just kind of see how they go. Like I don't think the quality of the data will be the same as for the green feed, but if you have a whole lot more data, then potentially we can work with that.
And just to, I think there's one, someone's asked a very practical question. Are the green feeds available after CRV and before they go back to LIC? I think both of us can answer that and say no. The green feed machines are really good, but they are not in themselves. There are some challenges with portability, and because of our need to ensure that they're always there available for this trial, they only ever move between those two organizations, and they're used for a very large proportion of the year. So they're not, but we do have others on order that will be available for hire. Currently, we have 8 up at LIC. There are now 4 located at Dairy NZ, and I have all located in grasslands, 2 for in Palmerston North, 2 for large animals, 2 for small animals, and I have another 8 on order, which I hope will be here by Christmas. But if anyone wants to look at the availability or wants to know the availability, they can just give me a ring. Or just drop me an email. And Lorna, just to finish on a really, really positive note, someone said they could be interested in a master's PhD and they'd like your contact details. If they can always contact the NZAGRC and we can forward on to Lorna. So you may get a reward for your excellent talk, Lorna. But thanks everyone. Oh, have I got a? No, I've got another one. Yeah, so that's done. They've given your email address, Lorna. So that's great. So what I'd really like to finish on is to thank you for that excellent talk and responding to that broad range of questions that were answered. And I'd like to thank everyone for joining today. If there are any more questions you think of afterwards, please submit them to either us or to Lorna, and we can get them answered. Please, many thanks for joining, and please look out for other webinars in our State of the Science seminar series. So thank you and good afternoon.